Hello everybody, it's Mr. Kent again, and we're going to be talking about math. Today we're talking about scientific notation. I'm just doing an introduction. We're not going to be talking about adding, subtracting, or anything like that. I just want to tell you that scientific notation is just really about moving the decimal. Alright, so if you get that, you're going to be good to go. Alright, why do you need to know this? Well, it provides us, meaning everybody, a way to use huge numbers like 4 trillion, I don't know what that is. It's too many zeros. It's 4 something something 0,000 kilometers, for example. It's too big. And really small numbers like 0.00000000023 meters, for example. So it's a very small number, and teeny in size. This is very huge, large in size. So how do we make that easier to deal with? Well, who uses this? Well, we have scientists, astronomers, since they're talking about distances from here all the way out into space. Architects, when they're building buildings, they have to know how many inches or feet something is, and it may be a long number. Engineers, they may be building machines or factories, and they have to design things with very specific distances or numbers. Mathematicians, of course, anyone who does math, they work with scientific notation. Doctors, maybe they just have to know the amount something is, like medicines, and they may use scientific notation to describe it. And contractors, people who build houses, they have to know distances and how much wood they're using, so they may use scientific notation. All right, here we go. Whoa! That's falling on me. We're good. All right, again, just moving the decimal. We're actually going to start doing this right now. I'm going to ask you or tell you to convert, which means change, from scientific notation to decimal form. Decimal form is just the numbers that we use all the time, whether or not they have a decimal in it. But we'll see. Look at this example. We have the number 7. Doesn't have a decimal, but there is an imaginary decimal right here. It's just a whole number 7. We call that the digit column right here. To the power of 10. Now this side has the power of 10 number, and this one has 10 to the second power. So how do we write this in scientific notation or in decimal form? 7, and we're going to move the decimal over 2 spaces. 1, 2. Since this is where the decimal was, we put 2 zeros there to fill it up. This is where our new decimal is. So the scientific notation number of 7 times 10 to the second power is now 700. Okay, we just moved the decimal over from where it was 2 places to the right because it's positive. If it doesn't have a number or a sign in front of it, it's always positive, and we always move that to the right, and we get this number 700. Let's try this one. First, we have our digits. In this case, we have 2.2, and then we have our power of 10. Here we have 10 to the negative 5 is how we would say that. So let's try this out. We're going to write down 2.2, since that's our starting number. We have a negative sign in front of that 5, which means always, whenever we have a negative number, if we had a number line here, if you watch my number line video, we know that negative usually goes that way from the 0. So I'm going to actually move this over to this side. Now that I know, I need to move my decimal over this way. So how many times are we moving the decimal? 5 times. Let's start from here. 1, 2, 3, 4, 5. Now there's my new decimal. I'm going to fill these with zeros, as always. And my new number in decimal form is 0.00002. Now I don't put another decimal in there. We can only have one decimal in the number. Okay? It lets us. It's the difference between all the smaller numbers and all of the whole numbers. And that is my new answer. All right, let's try it on this one. We have 4.923. We would call this our digits. And we would call this side, the one that has the 10 and the 5, the power of 10. Okay? Let's go ahead and write down this number exactly as we see it, 4.923. And now we're going to move the decimal 5 spaces to the right. Okay, because it's a positive number. So we're going to go 1, 2, 3, 4, 5. This is our new decimal area. We fill the spots with zeros. Our new number is just bring everything down like you see it, 2, 3, 0, 0. And if I count from 3 over, I have a comma. And our new number is 492,300. And that was all written in scientific notation up here. All right, now let's go back the other way. Let's say we want to convert from decimal form to scientific notation. That's taking the regular number that we're used to working with and changing it, convert means to change, to the scientific notation. And this is how we do it. First, let's look at this number, the mass of the sun. And mass just means how big and what it's full of and how much it weighs. And it means a lot of different things, but the mass is how big that puppy is. Well, it's one. See, I don't even know what this number is. It's just too big and too many zeros. I've never learned past maybe billions or trillions. Well, there's zillions and stuff, but there's just too many zeros. So I'm going to pretend that my decimal is right there, like it usually is. This is a whole number, and I'm going to count how many spaces till I get to where I usually put my decimal. There has to be at least one whole number on the left side of the decimal. Okay, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. I'm going to write that number down real quick before I forget. 30. I don't want to count that again. All right. Now, I have this number. I'm going to take out this comma so you don't get confused. I have a 1.988. And I want to write that down just like I did in my previous examples, 1.988, because I moved the decimal from there to there. Well, how many times did I move the decimal? Well, I moved the decimal 30 times. In which direction did I move the decimal? I moved it that way, but remember, if it started here, I would be moving the decimal this way to the right, so therefore the number is positive 30. So I'm going to write 1.988 times 10 to the 30. Because if I wrote this out, I would be moving the decimal from here 30 times that way to get that number. And now that is our mass of the sun in scientific notation, 1.988 times 10 to the 30 kilograms. All right, let's try another one. How about the distance inside of a microchip? Microchips are small little things that go on the computer and they process all the information. Well, here we have a number, 0.0000256 meters. So let's convert this from decimal form to scientific notation. I'm going to take where the decimal is. I'm going to move it to this position because I just want a regular whole number on the left side of the decimal, just one digit, and I don't care how many are after it. 1, 2, 3, 4, 5, 6, 7. All right, so I'm going to write that number right up here, 7. I may go ahead and write down 10. I'll go ahead and write down my X, and look at this number right here, 2.56. 2.56 times 10 to the 7th. But if I started out here, which way would I be moving my decimal? Over to the left. So if I move to the left, I just put the negative sign right there. And this is the distance inside of a microchip in scientific notation. Okay, now I want you to try it. All right, practice. You can do it. What I want you to do is press the pause button, and when you do, try working on these numbers and follow the directions. And when you're done, hit play, and I'll show you the answers. Hit pause now. Good luck. All right, welcome back. I hope you hit pause, or else that would look funny. Convert from decimal form to scientific notation. I'll do these real fast because you're just checking your answers. All right? My decimal would go here. I'm going to count how many spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I have 2.34 times 10 to the 17th power. And that is that answer right there. This one right here. My decimal would go here if we were going to write it down normally. 1, 2, 3, 4, 5, 6. So that's 6 times 10 to the negative 6. Since I moved it back this way, 1, 2, 3, 4, 5, 6 times. That's your answer. Now, to decimal form. 9.8, 10 times that way. So I'm going to write 9.8. I'm going to go this way 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's my new decimal. I'll take that out. Fill the rest with zeros. And that is my answer, 0.0000. As you can see, how many zeros? 10 times 98. There we go. And this one right here, 2.34 times 10 to the 17. I don't even need to write this out. Because if you paid attention, this answer is the same as this one, which means it is that number right there. All right. I hope you got it. We'll go over it more in class tomorrow. Until next time, adios, chicos.